sustainability seminar, and we have Mike Steinke from Oklahoma with us, and his company is Wind Energy Consulting and Contracting, and he works in the area of wind energy, and we feel this is an important area for us to understand better. So we have a program on it, and we're going to encourage him to help us understand this better. And Mike, we really appreciate your taking time to come up and visit with us, and we look forward to learning a lot about wind energy.
Good, my pleasure. Appreciate it. As Professor Erickson said, my name is Mike Steinke. I'm the Business Development Manager for Wind Energy Consulting and Contracting. I handle everything in my staff west of the Mississippi, Canada, and Illinois. I have a counterpart who does all the good stuff. He's got South America, the Caribbean, and the eastern part of the United States. We work everything from small 25 kW size turbines, which might go at a small school facility, up to the largest project that I'm working on is a 1,000 megawatt wind farm. That is 25% of what T. Boone's Pickens is putting in, if you wanted to look at sizes. And we operate in all different areas. We also do solar water, and we do geothermal. Just a quick synopsis of us. I got a lot of slides, so I'm going to go kind of quick, if I can get it to go at all. Okay. I started this program on the 2030. That's the 20% wind by 2030. This was put out in May of 2008, so a lot of the numbers you're going to see here are relatively current, although this industry is changing by leaps and bounds. They wanted the U.S. to rethink the energy mix. You can read most of this stuff here. The important things were, do we have sufficient resource? They wanted to determine that. Yes, we do. We have enough resource, financially feasible land resource, and offshore resource to power over 8,000 gigawatts of power. That means we can sell it if we chose to. Huge number. Technology requirements. Those hold us up. A, towers, cost of steel, cranes. Our cranes can't get up any higher. You want to know why you see wind turbines where they are and not higher? We don't have the technology to get the cranes to put the towers up any higher. That's an engineering feat that's going to have to be fixed. That kind of jumps in with manufacturing capacity. We'll cover a slide on that here in just a little bit. Key impacts. How is all this going to impact everything? Can the transmission infrastructure accommodate 20% wind? Currently, no. Cannot do it. And then environmental impacts. The vision. First off, productive tax credits. And these first slides I'll really blow through, and I'll get more into them as we kind of slow down a little bit. These are the godsend of the industry. If you generate renewable energy, let's talk about wind only here, you are paid, currently it's 2 cents a kilowatt hour. These are due to expire at the end of the year. They started at $0.015, and they're tied to inflation. If they renew them, they will probably jump to 0.021. They go up almost every year. Very important. 3 times we have allowed them to lapse. If you look at the amount of installed capacity, you see where it stops. It is estimated that if they do not renew this in this legislative session and don't get it done next year, you will see wind development drop by over 90%, which is going to put somewhere in the neighborhood of 200 and some thousand people out of jobs. Huge incentive. Electrical energy mix with no new wind. You've got hydro, you've got coal, nuclear, natural gas. By the year 2030, if 20% of it was wind, you see the shortening of the coal particularly. I'll show you some slides later on how that's going to impact our environment. This is hard to make out. It's installed wind nameplate capacity by state. You're going to have a hard time envisioning that. And then again, the annual and cumulative wind installations by 2030. Annual installed capacity in gigawatts. This is the plan on how many to get it done by 2030. How many gigawatts have to be installed, and then cumulative as they grow up. To get this done, to get 20% of our energy by wind. Of that 20%, 1/6 will be offshore. That is the plan to get it done. But line capacity. Conceptual transmission plans. You notice this in the red? This is what we have, okay, of high transmission lines, 765s, 335s, different size lines. All that stuff in the green, that's what we want. This is another transmission line map showing where they want to run it. Notice where you are. Kansas is going to play a major role in these lines. A lot of them are planned, a lot of them are going to happen, but they've got to happen before we can get the 2030 plan to work. Busy slide. Let's talk just a little bit about, let's go with CO2 first. Everybody likes the environment. 20% wind scenario. There's a cumulative total of 7,600 million tons of CO2 that will be avoided by 2030. And more than 15,000 million tons of CO2 avoided by 2050. In the big scope of things, that is about 8 or 9% of what that we can lower what's going to happen. And what where we're getting this from is by taking away coal production, by not using as much coal for the CO2. Security, energy security. If we diversify our electric portfolio, we don't have to get so much from other countries. You know, we're not going to be importing. Everybody knows that. We're going to import as much oil. Local economies, new income sources for the rural landowners, great tax revenues for the counties that this is going into. In Oklahoma, we've got a few counties that actually have production credits now on some of the turbines, or production taxes on some of the turbines, and you've got some rural schools out there that are very, very wealthy that are now looking at putting their own turbines in. So that it's a great bone for small rural areas. Workers, I'm going to show you some slides a little bit more on that, but we'll talk about the working and the job functions of what they anticipate, numbers, different types of jobs are going to be. Impact on employment, direct impacts, on-site, everything from construction workers, management, administration, cement, road crews, maintenance, off-site, boom trucks, blades, turbines. The word engineer isn't up here. But engineers currently in our industry, we need about 14,000 more engineers today right now in the renewable energy industry, wind only. Last year, there was a couple of years ago, there was 800 that graduated and went into the energy engineering field. Huge opportunity for you. I know that in our technology center in Jacksonville, Florida, it took us almost 6 months to find 3 that fit the bill. Very hard, pay them a lot of money. Indirect impacts, supporting business, bankers, financing, construction, contractors, equipment suppliers, and then of course induced impacts, everything from grocery store clerks, where they're constructing things, to hotels, management, so on and so forth. Back to annual CO2 emissions. Avoided vertical bars would reach 825 million tons by 2030. Lot of avoided CO2. Another slide, avoided emissions would nearly level project growth in the electrical sector. Somewhere in the neighborhood of, I'm going to tell you wrong, about 50%, similar to what you're going to see on water, of your CO2 is coming out of these type of coal-fired environments. And we will be able to lower that considerably by wind. Manufacturing. We talked a lot about this earlier. These little green dots show you where the manufacturing of wind parts and turbines and towers and blades are in the United States. Most of these facilities are support-type structures where the technology is coming in from overseas. You will notice that many of those are in what's formerly known as the Rust Belt. We need to move these to do 2030 into this area here. I can tell you from Oklahoma's standpoint, we are aggressively looking at it in the legislature. I work with our legislature on bills the last couple of years and will be on this year, and we're aggressively looking to do some things there. That's where the wind is. That's where they need to be putting these things together. Manufacturing, though, we are way behind the curve. Economic impact. These are, if you do 2030, the blue graph shows you the cumulative job totals, both from construction jobs and direct jobs. Ones that are construction, meaning they'll go away once it's done, and then direct jobs. Huge opportunities. 274,000 temp, 71,000 permanent. 507 temp, 161,000 permanent, if the manufacturing facilities are brought in to do that. All these numbers are based on the United States saying we want 20% of our power from wind by the year 2030. And again, reduces vulnerability, reliance on natural gas from Russia, Qatar, Iran. Less than suitable. We're all living through part of that right now every time we go to the pump. My favorite slide, second favorite. Nobody can own the sun. No one can own the wind. And it's why solar and wind power aren't deemed feasible. Because somebody can't go out and buy those and bottle them and sell them to you. This current wind facts is actually a little bit dated, and it's only about a 4-month-old slide. It changes so much. So I apologize there. We currently are the leader. It didn't take us to 2009. We took over in June. If my memory serves me right around June. And the gigawatts installed is closer to 6. But it does show that we're fastly moving forward with it. Again, we were laughing about this earlier. These installed wind maps need to be changed almost daily. Oklahoma's over 700 right now, and if I'm not mistaken, Indiana's actually got one up there now also. But here again, you see that Texas, for obvious reasons, Oklahoma, Colorado, great state, Iowa, great laws, Minnesota, a lot of opportunity in Kansas, a lot of opportunity. Why wind? Reduces electric bills. Creates jobs, provides energy security. Eliminates imported fuels. Short construction time frame. They go up relatively quick, and you want to put them up quick. They don't make any money unless they're up. We can put up small ones inside of 2 weeks if the weather works out with us. Deregulated markets help, in theory. In theory. Government mandates and incentives, there's a slide coming up, we'll touch base on that a little deeper. No acid rain or global warming emissions, no environmental damage from mining or drilling, no hazardous waste, no depletion of natural resources, no use of water for production. Land. One of my favorite numbers out of this whole 2030 statistic for lack of a better term, to accomplish the 2030 from land. How much land will it take? We get that all the time. It will take the size of Rhode Island. If you've ever been to Rhode Island, you can get through it really fast. So it doesn't take a lot of land, but that's the land mass that is estimated to be taken up. When we put up a utility scale wind turbine, something from a 1 megawatt and above, I'm going to give you some general numbers. For each turbine that we put up, it takes approximately 5 acres of land during the construction phase for us to come in and use. When it's done, though, it will take about an acre of land to 3/4, depending on the size. And that's usually your access road and your footprint. And these are the bigger ones. So in general, it's not a lot of land, but when you look at it all together, it's about the size of Rhode Island. Sources of our electrical power current are in 06. As you can see, hydro, other renewables, natural gas, petroleum, nuclear, other, coal. We were stuffed in with other renewables at this time. we were 2.4%. We're actually like 1% in wind. Trends for future costs, obviously oil, gas, they're going up. The cost of the wind, when we say zero, isn't necessarily truly zero. But the beauty of it, if it costs you 5 cents a kilowatt hour to put a turbine in that's going to last 25 years, and you've run your O&M and your inflation numbers in there and they're proper, 20 years from now you're producing that electricity at 5 cents. You pay 5 cents now for electricity from coal, your electrical company, you aren't going to be paying 5 cents 20 years from now. That's where they really start to make their money. That's where they come in and really put a dent in things. Cost of wind power has dropped dramatically over the years and will continue to go down. Right now we can put a wind farm in for 5.5 cents in some cases, 6 on average. Financial incentives. REPs and production tax credits, a little different, operated the same way. It's on production. Businesses get those. Unfortunately, schools can't. It'd be great if you could. They last for 10 years. This is what makes the wind farms that you see out there work. If I put a wind farm in and my cost is 6 cents a kilowatt hour to put that farm in, and for 10 years the government gives me 2 cents, which is what it actually is right now, gives me 2 cents, my cost now is basically about 4, because I'm going to have that farm paid for in 8 to 10 years, or you're not going to do a large farm. You put into that the green tags, the carbon credits, and I would guess that most of you are familiar with green tags, carbon credits. Those generate, depending on what state you're in, those go anywhere from, unfortunately in Oklahoma, a half cent a kilowatt hour to maybe a penny, to if we all lived on the East Coast, we'd be getting close to the teens for some of them. But in general, when we run financials, in most of the Midwest, it's 2 cents. So I've got this farm out here, and the government gave me 2, and I just got 2 more. Now it's costing me 2 cents to put it in. So you can start to see where the math on these farms work. An actual case, mentioned this when I was talking earlier to the professors. We've got a farm in Nebraska that we're breaking ground shortly on. It's a $230 million project, 96 megawatts of power when it's done, scattered out over about 6 square miles of land. At the end of 25 years, that will show a positive cash flow of over $550 million. That's a beautiful wind farm. Produces power at a set cost, creates revenue, helps the environment. CREB bonds, I'd love to talk about them, but they're all gone. We're hoping they'll bring them up again. It's a great way. Basically, you're selling the bonds and getting a tax credit for interest. They're the people that are buying them. It's a great way for schools, actually, but it's a little cumbersome. Accelerated depreciation. You can depreciate these things in 5 years. Beautiful. Financial people love it. And low interest loans and grants, again, state by state. I would be unfortunate to say that Kansas and Oklahoma, who sit in some of the best wind in the world, those 2 states combined are behind the curve on grants and incentives from the states. I'm hoping legislatively we'll change that. Renewable portfolio standards, what's going to help change that? The renewable portfolio standards, as you see in the white, are also known as mandates. In Oklahoma, we will never, ever have one passed at the state level. They work by telling your electrical companies, and there's different industries that have to abide by it, but I'm going to focus on the electrical companies because Arizona is a prime example. They just went through one with APS. They told them they had to produce, I believe it's 2% of their power by renewables. They can't do it. So they, at this stage, just 2%. They are going out to New Mexico and buying renewable energy credits. So for every kilowatt hour, megawatt hour, that they produce a power that isn't renewable, they have to buy the equivalent in a renewable energy credit to prove they did. And in theory, how they work then is you buy those, I'm in New Mexico, you paid me for my project, that will allow me to expand my project, and I again will create more renewable energy credits. They prefer that you buy them from the state, and some states have some mandates. Illinois prices those through the state. So they have some limits. In states that don't have those, like our state and your state, they're not worth as much money. We believe that after the election, and it really won't matter who gets in, although we do believe that if the Democrats win the election and maintain control, that you will see a renewable portfolio standard come through nationally. And if that happens, you're going to see wind, solar, balloon, because it's going to give them something to sell to run that price up, or pay for that project. A wind project is a 1,000-step process, which I'm not going to show you 1,000 steps. But basically, we do a wind resource analysis, and on a one-off or two-off job, meaning 1 or 2 turbines or a small turbine, we don't put a Met tower up. Even on industrial-sized turbines, we don't always put a Met tower up for a year. Why do wind farms put the Met towers up? There's 2 reasons. One is that guy that's going to loan you $200 million wants to make sure the wind is there. He needs to know that, because the studies that we're going to do are going to be very, very precise based off those Met towers and SODAR units. And we are one of the only companies that actually use SODAR units that we move around. So our data, we believe, is a lot more accurate for our customers to allow them to get a very accurate capacity factor on what that turbine is going to produce. The turbine manufacturers are going to give you a degree of guarantee on capacity based off that information also. They can't do that if they don't know comfortably what that wind data is. So that's why you see and you've read or you heard that they have to do studies for a year, 2 years. Environmental economic study, we'll get into a little bit more of that in just a second. Generator selection. There's a lot to that based on height, blade. Certain turbines are better in lower speeds than others. There's a lot to it. We have a database that has somewhere in the neighborhood, if I was looking and including tower heights and blades, we probably have over 400 combinations in our database that when we start to feed in the information to pick the turbine that we think is right for the project. FAA and local permits, got to have your federal aviation. They want their $650. Community buy-in, obviously we want to talk to communities. And then the utility interconnect study. Depending on size and time, very frustrating, very expensive. $10,000 the first time on average, $50,000 for the second phase, $250,000 for the third phase. This is on wind farms. We order your wind turbine. We then do the construction, foundation, put the turbine up, interconnect, and turn it on. What are the criteria? You need Class 3 winds. Wind is gauged in different classes. From 5.5 meters a second to 6. It goes from 1 to 7. Usually you're going to see 1 through 5. Up until a year or two ago, if you were under what's known as a Class 3 wind, you were not feasible to do a project. There are some turbines out there now that high Class 2s makes sense to go ahead and do a project. The technology is catching up. You need to be paying at least 6 cents a kilowatt hour or above. You all are, I guarantee. I haven't found anybody in the last 2 years who's been paying 6 cents except some government agencies. Normalized wind speeds in 7 to 9 meters a second. At 50 meters. We do measurements at different levels. Now the capacity factor. What exactly is the capacity factor? Your turbine's going to be rated at a certain size, and it's going to put out a certain amount of power. Our study will say that during that time period, you will get the capacity, the maximum amount of power on that turbine for that time period. What's that mean? Why are all the wind farms in Oklahoma and Kansas out in the far? Because their capacity factors are in the high 40s. That means they are chugging lots of power. If we do a study for you and you drop under 25%, it probably doesn't make sense for you to put a turbine up, even at your school. Utility rates, the power purchase agreement. If you're not going to go behind the meter, and there's a slide I think next on that, if you're not going behind the meter, then you need a power purchase agreement. Individuals don't do that. Wind farms do. Cost anywhere from $30,000. Most expensive one we did cost them $100,000. So again, a lot of money involved in these deals. A POG is basic. You don't see them very often. It's a power purchase agreement for somebody with a small turbine, but it's very rare. And net metering. The most important aspect of a wind farm, a small wind farm, or a one turbine project is net metering. And what that is, and every state is different with their net metering laws. It means in Oklahoma, if you have a turbine that is a 100 kilowatt turbine or down, meaning its nameplate is 100 kilowatts, if the utility charges you 9 cents for power, when you're on with them, they have to give you 9 cents. So it allows you to get the maximum amount. In Oklahoma, there's some twists to it. You can use your credit. You're going to generate more power in the winter when the air is denser and blowing stronger. You get more power. Then in the summer when it isn't, you can use your credit up, use it up. At the end of the year, though, if you have an excess in Oklahoma, they don't have to pay you anything for that. Our laws are not very good. Your net metering laws are actually worse. I think your what is it, 20? 0. Yeah, that's right. You don't even have one. I'm thinking in Nebraska is like 20, which is something you'd put it, well, you wouldn't put that at your house, but it's almost that size. Wind resource, and you guys are good. You're in class 4 winds in general, right here. This is why you're seeing some of the wind farms out in the areas that you do see them. 3s are good too. And again, this is not a high resolution map or a real involved map. This is just kind of a quickie to show you where you're at. Kansas got great wind. A U.S. wind resource map. Red is your best color. Where are they? They're all here where people live and don't want to see them, even though they'll be about the size of a pin. They're that far out. Always your offshore is much better because it's always blowing. Where's your second best area? Through here. Great states, no transmission lines, no people. There's nothing up there, so you won't see anything there. So that rolls it down into Nebraska, which unfortunately is the only state in the union that the state owns its utility company. Not real conducive for individuals to go in there and put turbines up, although we have one project there. And then you're into T-Boone Pickens land right here. This is T-Boone owns all this, except my guy owns a little bit. If you looked at that high resolution, you're going to see a lot of red in there, though. This is a, you'll see a lot of pockets of red. That's the corridor that Pickens talks about. That can generate more power than we can use. And all it's going to take is saying goodbye to Rhode Island. That's the only amount of land. I mean, that would be 20%. If we really wanted to get in the business of exporting power, 8,000 gigawatts, way more than we use, that's where it's got to be. Birds, bats, and wildlife, another one of my favorite topics. I will give you my favorite statistic about birds. The state of Wisconsin did a study on bird deaths on turbines. And I'm not saying this lightly, because we certainly aren't going to put up a turbine where, there's a wildlife where they're flying through all the time. But they did a study, and they found out that if you looked at every turbine in the United States and the amount of birds that it killed, that the stray cats in Wisconsin actually kill more birds in a year than all the wind turbines in the United States. I'm not making light of that, but it's less than 2 birds, and you hear it all the time, it's less than 2 birds a turbine. So they have come a long way with things to try to stop that, and they've done a great job at it. You're not going to put it through an avian path. It isn't going to happen. Same thing with bats. If you do, you really shouldn't be in the wind development business. You see there that buildings are by far number 1, then cats, others, whatever that is, tension lines, vehicles, pesticides, and this chart says under 1 for wind turbines, or yeah, that's for 10,000, but I know the studies say in the life it's about 2 a year. We do a shadow flicker. This is the latest of hot technology things to watch out for in our industry. Early in the morning, late at night, dawn and dusk, about 15 minutes, the sun will hit those blades at just the right angle that in some cases you will catch a flicker out of your eye. They're concerned about epileptics. I know of a case with a college. We did the feasibility study, but they had someone else do the turbine. When we did the study and did the flicker, we noticed that there were 5 homes that were going to be impacted by that. Luckily, all 5 of those people had no medical issues, but we didn't want to take a chance and find out the hard way, and the college didn't want to get sued. So the college walked in and said, we'll put new wood blinds in all your homes. Real nice shutters. Every home said, you betcha. So the point is you can work around the issue. And that's what we try to do in our company and make sure that it works for everybody. They got their turbines up, they're happy. Noise, at 50 yards, one turbine in normal wind is about as noisy as this. Have you heard any of them lately? They're very quiet, very quiet. I stopped last time I was out in your western part. I stopped, stood by the side of the road, and there were a bunch turning. I couldn't hardly hear them. It's not the issue. As long as you've got an upwind turbine. Some downwind turbines are still out there. These big ones aren't, and they're a little bit noisy, but even they're way better.
Low frequency noise,
Yeah, that's another issue, and with our studies, when we do noise, we will include that. It's more, everything that we've read and heard is it's more of an issue with animals. And it doesn't have near the distance, and it's mainly because their hearing is so much more susceptible to it. But we've not had any issues with it in any of the studies that we do. And what we'll do is plot this out. We'll run it and then plot it out by distance and different frequencies to how far you can hear it.
Is that the same for older turbines, like 750 kilowatt ones, as it is for newer ones that are 3 megawatts?
I can do a study on them. There is something to be said that with age, you're gonna stand that chance, but that doesn't mean that you can't update that to try to stop some of that issue. The biggest issue is between a downwind turbine and an upwind turbine in noise. Is that wind going to cross that tower in the cell before it hits the blades? They're a lot more noisy than what you see normally. But yeah, you bought one today, you bought one 10 years ago, you're probably going to have a little difference. Wetlands, we do a full wetland study. Visual, we just did a wind farm visual for another company that wanted us to do their assess work, and it laid out 47 turbines, and we did it from 365, and you can actually walk through the turbines in our visual. So they can look at it from the ground up. It's all computer simulated. It's pretty fancy. What's not up here, which is something else we've just included, one of the only companies to do it, thankfully, because I've got a job in California, we had to do the archaeology studies now. So we had not only bore down to see what your ground is, we want to make sure there isn't any relics under there that you're going to discover when you put your foundation in. Truth about birds, this was a repeat slide. A little bit different number. They say 0.75. I asked them how you could kill 0.75 bird. Should be at least one. Why are they so high? Wind power cubes with the energy you get cubes with every meter a second the wind blows. Any mathematicians, engineers are going to, that's huge. That's why you want them up. Also, the wind tends to blow without near the turbulence the higher you get. This is a study we did for the Mayport Naval Station in Florida. It was a high degree study. We put the tower here. We took some information. We correlated it down. We then go out through our database and we find other similar projects that have the same type of terrain and issues, and we run the analysis against that. This thing came out at a 35.9 capacity factor, and I will tell you when they put it up, it actually came in closer to 40. So why do they do these studies before? To find out how good it's going to be, and then use those numbers to figure out financially how well you're going to do. Inside the fence, also known as behind the meter, usually smaller turbines. You put your wind turbine up, it pumps into your meter. In some cases, in some states, if your meter turns this way on small turbines, it will actually turn backwards. It's kind of a unique thing to see. It actually goes backwards, so you get that credit. In bigger turbines, you put 2 meters up, they measure, and they give you your credit. But you'll see inside the fence all the time. Small wind, 100 kW Furlander. Quiet Revolution, we're looking to sign a deal with these guys to represent them in the United States. Rooftop turbines, probably the best of that style out there. Here's the one you just put up. And I honestly don't know what the name of that one was. Yeah, I've never saw that either. It's a ground turbine. Just some examples of some vertical axis. You got to like the Germans. They put advertisement on everything. So you can do that. We've got schools, high schools, that are putting their names and everything on blades and towers now and the whole deal. Outside the fence, again, transmission. This is like what a college would do, possibly your college. Put a number of turbines up, get in the wind power business, sign a power purchase agreement, sell the power into the grid, take the revenue to help the school. Some smaller turbines. This is probably a 50. This might even be a 50, 65, something like that, and you've got some other 5s, 10s, that size. Large-scale turbines. Bottom left's one of my favorites. That's the ocean turbines. They're up 5, 6. They're playing around with large turbines. You won't see those on land because we don't have the cranes. This is a 20-megawatt wind farm. This one, I believe, yeah, I believe this was what I was going to say. I think that one's in Ireland. Offshore, the boat doesn't exist. This is a true story, Massachusetts Maritime Academy. Let me pop this up. This is why you do early stage studies. The federal government told all the military installations a few years back, get green now, we don't care what it takes, boom, let's get it done. The commander at the Massachusetts Maritime Academy said, put me a wind turbine on that hill. They put a wind turbine on the hill. They did no study. Came out great, saved $300,000. They were paying 16 cents, which in the East is about normal. It was blind. It was an accelerated installation. They put a 660 kW at 50 meters. They had $200,000 in savings in electricity, now expanded. $50,000 sold back to the grid. I love this difference. They got a nickel. They pay 16ths. That wasn't real good negotiating. They sold their RECs for 50. They came and asked us to do a study. I said, would you do a study, this was a couple years later, and tell us what we could have had if we would have spent $6,000 on a study. We did the study. We moved that turbine 127 yards to the west, 27 yards to the north, and produced almost $450,000 a year worth of savings. That's why in our industry there's a need for engineers and individuals to do the studies and put the numbers together. They were paid by grants and gifts and federal stuff. This is a school that just turned on. So these numbers you're looking at are our hypothesis. We just finished the Erie School District. They were paying $159,000 a year in electricity. They're now paying $58,000 a year in electricity. On their over-electrical, we find this probably one of the funniest things that has ever happened. About a few miles down the road, they signed a power purchase agreement with a nuclear plant that was not producing enough electricity. They buy the excess from this school. This school has 750 students in it. It was a $3.5 million project. It will pay for itself in roughly 10 years, and it will save them, over-generate $100,000 each year in excess sales to the nuclear power plant. Beautiful project. Never raised taxes on anybody because of the laws in Illinois. They were able to get enough grants and funding and payback that they're able to do that. $100,000 saved. We threw this one in just kind of ad hoc. We do a lot of teaching at the high school level. We connect all the schools that we've got free of charge into our database. We keep all their anometer readings off their turbines, and then we've created a 30-minute to an hour curriculum once a week for their science classes. They come in, we give them the computers, they get online, they share information, they talk from California to Florida to Erie to New Jersey, and the high school kids now are learning meteorology and also what's going on with green energy. It's just a little plug about us. It's something that we like to do. Oh, some of the founders, also known as God, and that's that. That was a lot of information fast. Questions?
One of the things I've always wondered, you showed where the manufacturing sites were for the turbines and the parts and stuff. Wichita is a city with a lot of manufacturing capability in terms of the aircraft industry. How come they never retooled and got into wind? I think that would have been a foresightful thing for someone to do.
Well, one of the reasons, I'll answer you almost backwards, one of the reasons you're actually seeing the Europeans now looking at us is because of the value of our dollar. Before it was opposite. So keep in mind it was more difficult to get here. Secondly, until all of a sudden oil went over $100 a barrel, this was fun. This wasn't a business. I mean, you know, come on. So now everything's picking up. The states that were aggressive, the old Rust Belt states that said, we've got plants that are huge that are just sitting here with all the cranes, all the sidings, all the ports, you know. So we've been behind. And we have the same frustration that you sense we have in Oklahoma. And we're working on some stuff down there, just as I hope and think your legislation is up here. Because I'd love to be able to put the parts together and then ship them up for you guys to kind of finish. But, but that's mainly why. It was an economic reason, and we just didn't care about it. And we were behind this part of the country was a little bit behind the 8 ball.
How do you change the politics in your state legislators and secondly in the federal level?
Well, at the state level, and for our company, I lead all of our legislative incentive or efforts, regardless of where they are. And I've worked with a lot of the legislation, and I made a comment at dinner tonight. 2 years ago, I might get a call a month. I got 2 calls at home at 8 o'clock last night. I'm not sure we're changing it so much as the industry is changing it. But what we're trying to do is make it a win-win, so to speak. We're trying to be able to, well, let's look at Oklahoma really quick for an example. We've got wind farms there that are producing power that they want to put up, OG&E wants to put up. They actually want to ship that power to the east. You can get 16 cents. You can get 8. They want to ship that there. Well, one of our initiatives to keep that power in Oklahoma, and we did say this, the regional area down here from Kansas, Oklahoma, Texas Panhandle, keep it in there is, you want to ship it? You've got a surcharge. You've got a surcharge tax. That doesn't mean you still can't sell it, but if we're going to pay for the lines as taxpayers in Oklahoma, which we are, our electric bills are up almost 23% the first 2 months of this year. And it's school year, first 2 months of school year, the schools that we're working with. We want that power in Oklahoma. So the legislators now are hearing it from all their people. And I go down, frankly what I do is I help write bills, I accumulate information for them, help negotiate with the utilities, so on and so forth. It's just a matter of learning. You know, you've just got to constantly talk to them about it.
Mm-hmm. How do you sell the visual analysis? I know with a lot of the cases in Kansas, that's the big argument against them, because they'll ruin the scenic visuals of the Flint Hills. And I'm wondering, how would you argue against that, to sell the
I can't argue against the fact that it's going to have an impact on the foothills. I cannot argue that point. Well, our visual study can, like if you were going to put one out here, we would come out, our technologists come out, and they first map your area, shoot it, do the whole 9 yards. Then we Google Earth it, we satellite it. Then we place your turbines, and they come in, and literally it's like a 3D montage that you can walk through. You've got the joystick. You can walk up the hill. You can see where they're at. On a simpler one, we'll place one, let's say, at the back of your college over here. We'll shoot it from 365. So anywhere in an area for a certain distance out that you would tell us you want, give me a mile out, give me 2 miles, give me 5. We'll shoot that out and then give you the actual scene of what that turbine is turning. And we also use that on the shadow flicker. There's nothing I can do to try to convince you to put one up in the Flint or in the hills. You know, I can put it up there, I can do whatever, I can show you what it's going to look like, but you're right, it's you know, it's going to be there. You know, I can say on the positive, when you look at stuff offshore, and you've heard so much about that, and I don't mean, and I'm not going to sound political here at all, those turbines off those things are so small that when you see the true view of it, it's almost ludicrous, in my opinion. There's my 2 bits.
Yeah, sure. You touched on a lot of things in your presentation, obviously, but what's the single greatest hurdle nationally that's going to be overcome in order to change this?
Transmission line, by far, by far. Texas, ERCOT is putting in 765 lines into 5 what they call clean renewable energy zones, CREZ zones that they've identified. The average utility homeowner will pay $4 a month, and that's somewhere between and I just cannot remember the exact number. I know it's between $3 and $7 billion project, but it's only going to cost them $4 to do that.
I'm going to debate with you a little bit and suggest a another thing that's important, and I think that's the public education so that people understand sustainability and the need for wind and solar and the need for change, and so that they appreciate the economics of it as well.
Yeah, and I'd echo that. On the social side, he's 100% right, because we still have people that really think you're going to wipe a whole flock of birds out. And you know, this isn't California in the 70s when they threw them up in those condor corridors and killed a lot of birds. Nobody in their right mind is going to do that. So just from that angle, all the way down to how can it happen? Those are huge numbers that have blasted through here, but they can be done. And there really wasn't enough time to get into even like the water. But did you know do you know what the number one use of water is in America today? No. Electrical generation. 50%. Irrigation's 34%. It's not a lot left there for us.
One of the big arguments we hear from our utilities is that, well, we still have to have a coal plant or a nuclear plant to back up all the windmills. How do you respond to?
Or when the wind stops blowing.
Yeah, when the wind
Well,
stops blowing.
I've got to tell you, you know, what, 6 months ago, most of Texas almost went black. The wind stopped blowing where all their wind turbines are. Never's happened before, and they had to switch on. There is no right way to answer that. I'm not ever saying that I truly believe you'd see us be nothing but wind until the battery storage capacities come down, or price of capacity comes down. Right now, I can go out and buy a battery to store all the power that my megawatt machine is going to produce, but Mitsubishi is going to charge me $1.5 million for it. So it doesn't work yet. So I'm hoping the technology gets to the point where you see where they can start to store that. But what you need to answer them is, you've got 8 plants. You're not always going to need 8 plants. If you've got this to offset some, particularly your peaks, and then use your coals use your coals when you have your peaks, and use your others and have them ready to fire, it can be done. It's a circular argument with them.
The main approach to dealing with wind is to start natural gas plants when the wind is not blowing, and natural gas is used for peak power much more than coal and nuclear is.
There's studies about the 20% that say we don't need extra capacity. 20% wind is not so much that you're going to notice
Right.
it.
Right.
More
But it
than
puts a
that,
huge dent in,
okay.
it puts a dent in a lot of things. And, you know, T. Boone is extrapolating this whole thing. And he's right. We could. Our country could do this. But it isn't feasible that it will do it to that extent. You know, it's...
We have another question back
So
there.
currently, is this wind energy, it's used right when it's generated, we can't store it, is that
Right.
what I'm hearing?
Yeah.
Okay.
There's no economical way to store that power today. I personally believe in 10 years you'll see it. I mean, we got excited last year when we heard that Mitsubishi actually had a battery that could store it and store it for a long time.
Well, there's a lot of talk about salt caverns as well, pumping air compression, and then
Yeah.
and then also MIT was this big hubbub recently about a research lab there finding a catalyst for hydrogen production for electrolysis.
There is
Where you take water and use electricity to split water into hydrogen and oxygen, and you can't be
Yeah.
hydrogen economy that we're all talking about here. But that would require a lot of water, so
Yeah.
you know, we're trying to get off of the whole water consumption thing. And if we wanted to be in western Kansas, we'd be confronting the whole water shortage issue once again.
Yeah. I would recommend anybody that wants further information, it's easy to find on the net. It's just called the 20 by 2030 report. You type that in, it's about a 250-page report, but it's typical of most government documents. It's about 120 written and a lot of graphs and a lot of blank pages. It will give you, it's probably the best overall primer for where we're at and what the country's vision in some degree is. No.
I think I'm going to bring this to a close. We try to let people look 10 till 8. And so let's give Mike a big hand.
Part of the family.